Newton's first law states that an object at rest remains at rest, and objects in motion remain in motion at a constant speed unless acted upon by an unbalanced force. This first law applies to tennis because a tennis ball will remain at rest until an unbalanced force is acted upon it, which in this case is a tennis racket. When the ball is hit with a racket, it is accelerating through the air and will keep moving at a constant speed unless air resistance, friction, or another unbalanced force causes it to stop. Once the ball goes over the net, gravity pulls it down for it to bounce once.
Inertia, which is also included in Newton's first law, is the tendency to remain moving with a constant speed. The moment of inertia determines the amount of spin the ball has when a racket's force is applied. Inertia also depends on mass, so in this case it would depend on the mass of the ball.
Newton's second law says that the force is equal to mass times acceleration. The mass of the tennis ball will remain constant, so that makes the acceleration evenly balanced to the force applied by the player. The harder you swing the racket, the harder it'll hit, and the faster the ball will go. Newton's third law states that for every action there is an equal or opposite reaction. One action-reaction pair in tennis is when the ball is pushing on the racket and the racket is pushing on the ball. Kinetic energy is energy dealt with motion. In tennis, kinetic energy is present when you hit the ball with the racket. When you hit the ball, the kinetic energy is released in the ball's motion. Also, when you throw a ball up for a serve, as soon as it becomes to fall downwards, kinetic energy is present.
Potential energy is energy dealt with position. Potential energy is present in tennis when you throw the ball up for a serve. When the ball reaches its maximum height, just before it comes down, it has the most potential energy. The equation for potential energy is potential energy equals mass times gravity times height. The mass of a tennis ball is 0.057 kilograms. The gravity is always 9.8 meters per second squared, and the height the person throws it up is 2.5 meters. Once you plug in the numbers, you just multiply everything together. So you take 0.057 kilograms times 9.8 meters per second squared times 2.5 meters, and you should get 1.4 joules. Work is the force applied to an object over distance. In tennis, the force, which is the tennis racket, and the object, which is the ball, is hit or served. It travels in the direction the force was applied, which is the direction the player hit it. Conservation of energy states that energy cannot be created nor destroyed but can be altered from one form to another. In tennis, this can happen when you throw a ball up for a serve. Potential energy is present when you throw the ball up, and on the ball's way down, the energy is converted to kinetic energy.